This is question 43 on chemistry from the 2018 NSAA. So the question gives you a list of the main reactions in a blast furnace for the extraction of iron, and it asks you which of the underlying substances, that's carbon dioxide, calcium carbonate or calcium oxide, are oxidized, reduced or neither in these reactions. Well, we need to look at oxidation states of the carbon dioxide and the product carbon monoxide. So what's a good rule to start with that we already know about oxidation states? What about oxygen is always -2 in compounds, except peroxides? This means we can straight away assign -2 to the oxygens in both the product and the reactant. And now we can work out the oxidation state for carbon in each case. So in carbon dioxide, we've got 2 oxygens, each contributing -2. So what does that make carbon? It's +4 to make it 0 overall. Similarly, for carbon monoxide, we've already got 1 oxygen contributing -2, and so carbon must be +2 to neutralize it. So now I can answer this part of the question. Is it oxidized, reduced, or neither? We have oxygen not changing, but we have carbon going from +4 to +2. What does that mean? It's gained electrons, and therefore it's been reduced. Okay, so what about this next reaction? We have calcium carbonate forming calcium oxide and carbon dioxide. We can use the rule that we've already used for oxygen to assign its oxidation states in each of these as -2. And so what else do we need to use here? What other rule? Well, we have calcium, which is a group 2 metal, and we know that group 2 metals are always +2 in compounds. So we can assign these straight away. And that just leaves the carbon to work out from what we have. So let's start with calcium carbonate. We have 3 oxygens, each contributing -2. That brings us to -6. What about calcium? That pushes it up to -4, sorry. And that leaves carbon as +4 to make 0. Calcium oxide is already done. What about carbon dioxide? We have 2 oxygens, each contributing -2. So carbon again must be +4 to bring it to 0. Well, what have we worked out here? We have +2, +4, -2 in the reactant, and +2, +4, -2 in the product. None of them have changed oxidation states, so this is neither. Now what about our final reaction? We have calcium oxide plus silicon dioxide forming calcium silicate. So let's assign the oxidation states as we have before. We can use the two rules that we've already used to assign calcium and oxygen's oxidation states. What do you notice now? Well, the reactant that's underlined is calcium oxide. Calcium and oxygen are both rule followers, as it were, so we already know that they can't change their oxidation states, so we can immediately assign this as neither oxidation nor reduction. And so our final answer is carbon dioxide is reduced, calcium carbonate is neither, and calcium oxide is neither, which corresponds to answer F on the question paper.